All right, and now we are talking. And welcome to SLU, everybody. Space for everyone. I'm Jerry Montour, your host and expedition leader here. And why that heavy metal intro, you ask? Because tonight we're taking a look at a long dead world in the middle of our solar system, the heavy metal asteroid known as 16 Psyche. Now, 16 Psyche is an asteroid floating around the asteroid belt between Mars and Jupiter. But even more interesting than that, scientists studying Psyche believe it might be the metallic core of a long dead planet, a planet that once was the size of Mars, or so they think. But first, let's take a look at our telescopes. As you know, Paul Cox normally guides us through this, but he's in Grapevine, Texas, speaking at the American Astronomical Society's 229th meeting. And if you're heading to the meeting, be sure to say hi to Paul. I'm certain he'll buy you a drink. But about those telescopes now, got a live look right now at the SLU Observatory panorama. You can see you've got pretty good skies, actually beautiful skies right now at the Institute of Astrophysics of the Canary Islands. It's a bit windy tonight, and we've opened up the domes just for this show. We hope the weather doesn't interfere too much with our live feeds. Of course, we don't just want to look at the telescopes, we want to look through them. First, let's check out the skies directly above the SLU dome. This is a live view using our all-sky camera. To the left of the view, you can see our SLU domes sitting wide open. They're pointing toward the subject of tonight's show, which is 16 Psyche. And we're hoping to show it to you using our high magnification telescope. Psyche is about 130 miles wide, or just 2 kilometers wide. That's pretty large for an asteroid, but it's also more than 230 million miles away. It will only appear as a very small white dot in the center of our feed. And I hope we can bring it to you. That asteroid, let's see now. Yeah, it's there someplace. Trust me. Aha, okay, see the red circle? That is 16 Psyche right in the middle of the red circle. That asteroid is the focus of a brand new mission just announced by NASA. A team of scientists is now in charge of mounting an unmanned mission to 16 Psyche, launching in the year 2023 and arriving in orbit in 2030. In just a couple of moments, I'll be talking with Dr. David Lawrence, one of the chief scientists of the Psyche mission, learning what they're planning, why it's so important to study this particular object. And then I'll be joined by SLU astronomer Eric Edelman to hear what we already know about these fascinating asteroids and what makes this particular one so very, very intriguing. Now, if you have questions for either of my guests, please ask them by tweeting to @SLU on Twitter or joining in on the live chat on Facebook. Don't go anywhere. I'll be right back with Dr. David Lawrence, so stay with us. This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon's shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on SLU. Space for everyone.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
All steps for man, one giant leap for mankind.
And welcome back to our exploration of the metal world, the distant asteroid 16 Psyche. I'm your host, Jerry Montour. We're looking live at that very world through our telescopes in the Canary Islands. As I mentioned earlier in the show, NASA has announced a mission to visit Psyche within the next 13 years. And here to tell us all about this mission and 16 Psyche itself is one of the men working on the project, Dr. David Lawrence, a planetary scientist at Johns Hopkins University. Dr. Lawrence, thanks for joining us. What do you believe this asteroid is or was at one time?
I think the best estimate that we have of this is, I'm sorry, I have actually a delay here of a few seconds.
Well,
I'm
we can
trying
hear
to.
you fine if you, yeah, you can put up with it.
Okay. Well, I'm gonna do it. Mute my speaker there for a second. We think it's a remnant core of a planetary body that formed originally in the early part of the solar system, and then likely had some collision that burst apart the mantle of the body, and we're sitting here left with uh, uh, a large piece of material that's 90% iron, nickel, metal, maybe a little bit of silicates left over from rocky material. And the way we're really thinking about it is this mission is giving us an opportunity to peer into the center of a planetary body that would never get to, for instance, on Earth. And there's no way we're going to drill down to the depths of the Earth and look at the core, but we have what we think is a planetary core sitting outside in the asteroid belt right now. And that's a very exciting thing to go and explore.
Well, we never had a mission to Psyche, so why do you believe it's made of metal?
The main reason is that there's radar measurements that have been made that show a radar albedo that indicate it's mostly made of iron, and it also has a very high density. It's a very large asteroid in the asteroid belt, and it affects the gravity of their bodies, and you can base both with its size and its gravity effect measure the density. It's a pretty dense body, so you put it all together, and it makes us think it's an iron-rich body.
In your considered opinion, what do you think Psyche is going to tell us about our planet?
Very good question. So I think it will give us information about how planetary bodies form in general, and what the different types of materials that you have that might be in the core, not only just iron, but we're going to be measuring nickel and other things and get at. And so, tell us general information about how planetary bodies form. There's still a lot that we don't know.
All right, pardon a layman's question here, but I understand the Psyche spacecraft will settle into orbit around the asteroid, hopefully in the year 2030. Why only orbit the asteroid? Why not land on it? I mean, it's pretty big, right?
Yes, but there's uh, you have to take a lot of fuel in order to land a spacecraft. There's big challenges of trying to get down that close to the surface. Um, that's been done for the Mir spacecraft, but that was done at the very end of the mission when you've done everything else you want to do. It's a risky move, and we actually can meet all our science objectives by going into orbit.
When do you hope to first start receiving information about the makeup, the true makeup of the asteroid?
You're going to get information pretty soon after you get into orbit around the asteroid. The way the whole mission goes is it's a tiered approach. You go into orbit at a pretty high altitude. You find out if you're safe. You're going to get good pictures of it. You're going to measure the topography. That in itself will tell you information. And then, as you know it's safe, you ease your way into lower altitudes, and you'll get more and more information. The instrument that I'm working on is called the gamma neutron spectrometer, and it actually
Mhm.
measures the composition of the asteroid using gamma rays and neutrons. But in order to make our measurements, you have to get pretty close, pretty much within one body radius. So our measurements will be the tail end of the main mission that we're going to get those measurements.
How long does it take for information to be transmitted from the spacecraft to Earth?
Um, it doesn't. It takes orders of tens of minutes, depending on where the asteroid is in relation to the Earth. And so it doesn't take that long. In fact, the kind of neat thing is you get the data that will go into the Deep Space Network, and then it'll show up on our screens pretty soon thereafter. And we're hoping that when we get the data, you'll be finding out information pretty quickly.
Well, it's fascinating. And by the way, there's a look at 16 Psyche right there inside the red circle. Doctor, you've been involved with a number of
that's a
asteroid
great picture.
missions.
I've never
Do you
seen it.
anticipate being surprised by what you find out there?
Oh, absolutely. You were showing some of the artist conception pictures, and these were attempts at trying to understand what it may look like. I think one of the big mysteries that a lot of scientists are wondering is what our crater is going to look like in a big ball of metal. I have no clue. I don't know. Is there going to be a soil? Every time that we go into space, you see big surprises. Another thing that we're really interested in is, given that it's a ball of iron, it might have remnant magnetic fields. We don't know that. The spacecraft's carrying a magnetometer to check for that. And if you have magnetic fields, you may have particles flying around. Almost guarantee there's going to be a whole host of very interesting surprises. We just don't know what they are.
Right, right. Well, this is a look at 16 Psyche from one of our telescopes in the Canary Islands. Doctor, what do you think of this shot? I think it's pretty cool.
Yeah, this is fabulous. I have not seen Psyche through a telescope, so this is the first time. So thank you very much. That's a great view, and it's really kind of neat to see where you're going to be going when you start taking your journey.
Well, you kind of touched on it, but no matter what we learn about Psyche, what other practical applications of that knowledge can be applied here on Earth?
That's the perennial thing of basic science versus applied science. A lot of what we learn information, it gives us information on how to understand geologic processes. Those kind of things can be applied here. I would also argue that technologies that we develop for doing these missions are also directly applicable in a whole host of areas. In my career, I've done various work for both national security applications as well as basic science and other environmental studies. I mean, you have engineers, you have scientists all working together, and you can take these applications and use them in many places.
Well, I was going to ask what inspired the mission in the first place, but I think you pretty much answered my question. It's a myriad things, right?
Yeah, it's an amazing body. I hadn't known a whole lot about it until a few years ago when I ended up meeting the PI, principal investigator Lindsay Alexander. And the more, excuse me, the more I learned about what this body is about, it is a fascinating place. In particular, for our measurements of gamma and neutrons, it's going to be a very exciting place to make these measurements. It's going to give us very different type of data than we've seen for these measurements. We've made these measurements at the moon and Mercury and other asteroids, and this is going to be way outside of our realm of experience. That's really exciting for a scientist.
Well, we've known about Psyche for quite some time. I think it was first discovered in 1852 or something like that. Do you remember your reaction when you got the go-ahead that you've been green-lighted for this mission?
Yeah, that was a couple days ago. I was in the office of my colleague, Patrick Duplowski, who works on this, and the PI gave me a call on my cell phone. I almost didn't answer it because I thought it was a prank phone call, and I thought, oh, what the heck? And she said, Dave, we've been selected, and I was stunned, and a very good stun.
I bet. Well, Dr. David Lawrence, thank you so much for the insight. Good luck, and you've got 7 years of fun ahead of you. Thank you so much for joining us here on SLU.
Absolutely. Thank you very much, and thank you for your interest. And please stay tuned. It's going to be exciting next number of years.
Oh, we will. Good luck. Dr. David Lawrence, one of the lead scientists on the Psyche mission launching to the asteroid in the year 2023. All right, coming up on the show, I'll be joined by SLU astronomer Eric Edelman to find out how 16 Psyche differs from other objects in the asteroid belt. So stay tuned. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slu.com.
As we celebrate our 13th anniversary, we're excited to bring you the all-new slu.com with an all-new reservation system, brand new telescopes, and introducing SLU Recommends. We're bringing the universe closer than ever before. Coming soon to SLU, where there's space for everyone.
And we welcome you back to our exploration of the metal world, the distant asteroid 16 Psyche, which you see in the center of your screen right now. I'm your host, Jerry Monteur. We're looking live at 16 Psyche through our telescopes in the Canary Islands in Spain. Earlier, we spoke to Dr. David Lawrence, one of the scientists working on the 16 Psyche mission. But what makes Psyche so interesting? What is it really? How can it help here? We want to hear from you, by the way. If you have any questions for us, please hit us up on Twitter or Facebook. Now, to find out why we're so psyched about Psyche, yes, I said it, we turn to SLU astronomer Eric Edelman. Eric, welcome to the show. This is a very special kind of asteroid, isn't it?
It absolutely is. It's really pretty much one of the rarer kinds of asteroids that we have out there in the asteroid belt. Like Dr. Lawrence was talking about a little earlier on in the show, we sort of see what those asteroids look like by looking at their reflections, essentially. So, sort of like how we look at ourselves in the mirror. There's sunlight that bounces off these asteroids and then it hits our telescopes, hits our eyes. And by the different sort of features that we see in that light, we're able to classify those asteroids in different ways. For example, the M-type asteroid, which is the sort of asteroid that Psyche is a little bit of a brighter asteroid because you can sort of think of how maybe a piece of metal might reflect light in the sun. It looks really bright. Then we have other asteroids, sort of some of the more common ones are S and C type asteroids. And those are ones that have a little bit more rocky materials involved in them. And particularly the C type has a lot of carbon, C type, and that makes it a little bit sort of dimmer, not as reflective. And S type is sort of right in the middle. And so we look at the M type, or we look at Psyche, we see it as an M type. And we also don't see too many more of those M types out there. They are in the minority of the type of asteroids that we see. The metallic asteroids are not the most common asteroid out there in the cosmos, so to speak. And it tells us a little bit about, seeing these M-type asteroids actually tells us a little bit that they are the rarity and how our solar system has formed into how it is today.
But it also could be, and they're hoping that it is an indication of how our planet was formed and the planets surrounding us, correct?
Oh, yes. So he was talking a little bit about how this might have been sort of a protoplanetary core, and that's a really interesting topic in terms of our solar system. Our solar system has formed over the course of, well, now it's 4.6. It's pretty old, essentially. And so we have essentially at first we had this bit of a nebula. We had a bit of a solar nebula that was surrounding our our system, and it eventually turned into our star and our planet. And in the middle, there was some little light dust and grains, these rocks that were in our solar system that eventually started crashing together and getting bigger and bigger, sort of snowballing into these very, very large objects. And so eventually, some of them became big enough to be planets, and those are the planets that we have here in our solar system today. Some of those didn't quite reach that age, and a little bit of that has to do with how sort of violent our solar system was initially. There was this cataclysmic sort of era where a lot of things were colliding together, and some of them ended up sort of coming to pieces, not coming together. And one of those possibilities is Psyche, where
Mhm.
where it could have been snowballing into this larger and larger object, but then was hit by another object. And what we're seeing is one of the remnants, one of particularly the internal remnants, because initially our solar system had this singular composition, had these different percentages of different elements and materials. And so some of the primordial objects in our solar system, some of the carbonaceous chondritic asteroids, so to speak, those reflect that primordial composition. And those were the objects that didn't quite get too big. But then there were other objects that kept snowballing, getting bigger and bigger, and also got really heated, really hot. Those objects started to undergo what's called differentiation, whereas the lighter materials headed up to the surface, the heavier materials sort of sunk into the center of that object, into the core, so to speak. And that's sort of what happened with our planets as well, is what we think. And so one of the reasons we think we don't see as many really uh, iron metal asteroids is because most of that stuff, that material, was got into the center of very large objects. And so one of the rare cases that we see that differentiated metallic core-like object is if there is some cataclysmic event that sort of got rid of the core and allowed us to see that inner object, the process of a lot of violence over many, many years.
Well, we just got a question from Mike on Facebook, and he was asking about something you just answered. He was asking why we don't see more metal or metallic asteroids. You just answered his question, so thank you, Mike, for that. Eric, it's called 16 Psyche. Where did the name come from?
Psych. So a lot of the original sort of bodies that we have out there in the solar system were named after stories that we came up with here on Earth. In my mind, I think it's sort of a way that we can try to relate ourselves to what's out there, put personalities on them, and things like that. And so you might actually recognize a lot of the names in the story I'm about to summarize real quick. So Psyche was actually a sort of a woman that was born on Earth, so immortal, and was very, very beautiful, and everybody started thinking she was so beautiful. But then Venus got a little bit jealous. So Psyche was like, "Oh, people should be worshiping my beauty, not Psyche's beauty." So she sent her henchman Cupid over to make Psyche fall in love with something terrible, something horrendous. Uh, Cupid made a mistake and cut himself with his own arrow and fell in love with Psyche. And so then Psyche and Cupid ended up getting married. But then there was all these issues, this drama that you normally hear about in these sorts of stories. Eventually, Psyche overcame all of that terror, all of the trials that she had to undergo, and was able to live happily ever after with Cupid. But things that appear in this story are we have Venus, we have Jupiter, we have Psyche. So these uh, these gods and these mortals, these ancient stories, sort of show up in our sky. How we've named our sky after a lot of these objects and imbued them with personality. Imbued them with beauty, imbued them with sort of the imagination that we expect to see from different characters in humanity. And so, yeah, Psyche is a little bit of a story of ourselves painted on the sky.
Okay, well, I love happy endings, as you know. And the number 16 refers to what? That
Oh,
16
so
planet like objects?
we originally we started numbering these objects, and so sort of keep them in order, and we've gotten a whole lot of numbers so far. There's a lot of these numbered minor planetary bodies, so to speak, and Psyche was one of actually the first ones that we found, and I'm not sure the exact year. I think it's in the middle of the 1800s that we ended up finding Psyche in telescopes. And to me, that's absolutely amazing because we're looking at this live image of Psyche right here
Mm.
in the SLU telescopes. And if you just see what it looks like this tiny speck, this tiny dot amongst just a group of specks and dots. And for somebody to be able to see, to sort of differentiate, to sort of see what that object might be in comparison with all the others, speaks of this incredible body of knowledge that we've accrued about the stars, about how much deep understanding that we had back then, and that we've
Mm.
sort of multiplied and multiplied into today. We're able to classify so many of these asteroids into different spectrals. types, into different compositions, iron versus stony iron. There's so much that we now know about this stuff. And I think that image that we see live on the screen really brings that to heart, because we're just seeing that dot. And from that dot, we can extract so much. It's incredible.
It is absolutely astounding. Eric, in your opinion, what could this mission mean to the average Earthling? Why should we care?
Well, I think there's actually a few different ways that this could really hit home for us. Just a little earlier on, we were speaking about how even if it isn't nearby to us, we relate the story of ourselves to the stories of the stars. But even beyond that, going out to the stars actually helps us learn a little bit more about us, because the core, even though we are so nearby to our Earth's core, it's so distant from us. It's not something that we can ever really grasp ourselves, witness ourselves. Just to give you a conception, how difficult it would possibly be to get to the core. The deepest humanity has ever dug is Russia super deep borehole, I believe it is, which is about 7.6 miles deep. Now, the radius of Earth, sort of cut Earth in half, the length of that is about 4,000 miles long. And so the crust, just the very top layer of our planet, is about 22 miles deep. So humanity digging by itself has only gotten about a third of the way through the very thinnest top layer of our crust. So it is infinitely easier for us to take a spacecraft, send it out about 3 times the distance that Earth is from the sun, hundreds of millions of miles out to the asteroid belt. It is infinitely easier for us to do that, visit a whole other object, look at that sort of approximation of our own core, instead of actually going to that core ourselves. That is, and I find that absolutely amazing. But so getting back to the question, the benefits we could get from this mission is learning more about what the internal sort of structure of our own planet is like. And I think that that could be useful in so many ways. I sort of think of it as similar to ourselves. Like, we, with a mirror, can look at the outside of our body, but can't really see our internal organs so well unless there's a big problem. But sometimes it's important to know what's going on with those internal organs. That can
Right.
be a big benefit to us. And in the future, maybe that will end up being very helpful to us. But also in terms of classifying objects in our solar system, knowing sort of the potential for what sort of objects are out there. We really want to keep a close look on all sorts of minor planetary bodies, see what might get near to us, what maybe we could mine in the future. I think there's so much potential here in terms of just furthering our understanding of how our solar system has come to be and what is in our solar system right
Eric, fascinating stuff as always. Thank you so much for stopping by.
now. Oh, absolutely. Thanks for having me.
SLU astronomer Eric Edelman. It's called the Psyche mission, and it happens in 2023. And that about wraps it up for us here tonight on SLU. We hope you enjoyed tonight's show. If you missed anything, SLU members can watch any of our previous broadcasts at any time. Do this all the time here at SLU, and you won't have to wait long for the next one on January 12th. We're celebrating the first full moon of the year, the full wolf moon. And we've got lots of great shows on the way in the coming months. The very first solar eclipse of 2017, right around the corner in February. The Ring of Fire will sweep across South America, the Atlantic, and parts of Africa on February 26th. And we're already making plans here for the big transcontinental eclipse on August 21st. The total solar eclipse will make its way across the entirety of the United States. SLU will be on site to capture the whole thing. So be sure to follow our ongoing coverage of this once-in-a-lifetime event. We hope to see you on a future show, but that's it for today. I'm Jerry Montour. This is SLU, Space for Everyone. Institute of Astrophysics of the Canary Islands. It's a bit windy tonight, and we've opened up the domes just for this show. We hope the weather doesn't interfere too much with our live feeds. Of course, we don't just want to look at the telescopes, we want to look through them. First, let's check out the skies directly above the SLU dome. This is a live view using our all-sky camera. To the left of the view, you can see our SLU domes sitting wide open. They're pointing toward the subject of tonight's show, which is 16 Psyche. And we're hoping to show it to you using our high magnification telescope. Psyche is about 130 miles wide, or just 2 kilometers wide. That's pretty large for an asteroid, but it's also more than 230 million miles away. It will only appear as a very small white dot in the center of our feed. And I hope we can bring it to you. That asteroid, let's see now. Yeah, it's there someplace. Trust me. Aha, okay, see the red circle? That is 16 Psyche, right in the middle of the red circle. That asteroid is the focus of a brand new mission just announced by NASA. A team of scientists is now in charge of mounting an unmanned mission to 16 Psyche, launching in the year 2023 and arriving in orbit in 2030. In just a couple of moments, I'll be talking with Dr. David Lawrence, one of the chief scientists of the Psyche mission, learning what they're planning, why it's so important to study this particular object. And then I'll be joined by SLU astronomer Eric Edelman to hear what we already know about these fascinating asteroids and what makes this particular one so very, very intriguing. Now, if you have questions for either of my guests, please ask them by tweeting to @SLU on Twitter or joining in on the live chat on Facebook. Don't go anywhere. I'll be right back with Dr. David Lawrence, so stay with us. This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon. And now we are talking. And welcome to SLU, everybody. Space for everyone. I'm Jerry Montour, your host and expedition leader here. And why that heavy metal intro, you ask? Because tonight we're taking a look at a long dead world in the middle of our solar system, the heavy metal asteroid known as 16 Psyche. Now, 16 Psyche is an asteroid floating around the asteroid belt between Mars and Jupiter. But even more interesting than that, scientists studying Psyche believe it might be the metallic core of a long dead planet, a planet that once was the size of Mars, or so they think. But first, let's take a look at our telescope. Did you know Paul Cox normally guides us through this, but he's in Grapevine, Texas, speaking at the American Astronomical Society's 229th meeting. And if you're heading to the meeting, be sure to say hi to Paul. I'm certain he'll buy you a drink. But about those telescopes, now, got a live look right now at the SLU Observatory panorama. You can see we've got pretty good skies, actually beautiful skies right now at the instant. All right,